Hello and welcome to today's webinar. My name is David Cash. I'm a member of the marketing team here at Mounts, and I'm glad that you have taken the time to join us today as we look at our topic of how to ensure screws are tightened in the correct fastening sequence. Now, if you have any questions about today's topic or any type of inquiry that you want to make, feel free to put those in the chat and we'll have a question and answer portion at the end of today's presentation. And so when we talk about sequencing and trying to control that sequence, this kind of goes hand in hand with the principle of error proofing. And kind of the generic definition for error proofing is kind of crafting behavior to allow the operator, in this case, not to have the opportunity to make a mistake. And so this is kind of the premise that we're dealing with as we look at sequencing during the fastening process. And the whole idea is we want to get it right the first time and help to prevent mistakes. And if there is a mistake, that we can go ahead and fix that and manage it, because a mistake is really only really happens when that mistake is noticed by the customer. So if we can fix it beforehand, then there isn't that presented. And this is all part of the poka-yoke strategy of being able to manage what the operator does, and again, crafting their behavior and not making mistakes during the apps or during the application process. And this is very similar to what you might see in real life. So if you have a grounded electrical cord and you go to plug that in to the outlet, there's only one way that you can plug that in. You can't turn it upside down and plug it in. There's only one way to do it. And that would be an example of everyday poka-yoke of the crafting the behavior around making sure that there aren't any mistakes that are happening. And so in the sequence and tightening process, what are some of the failures that we can see? Obviously, if we're trying to do a sequence, it could be one reason would be the sheer number of fasteners in an application that need to be tightened. We want to make sure that all of those get tightened and get tightened correctly. Another reason we may want to use sequencing is because we might be dealing with a gasket and or a flange type application, where if we tighten it fully down on one portion of the application, it's going to lift the other side of the application. So we may need to do that same sequence a number of times to be able to fully seat that particular application correctly. So those are some of the failures that can happen if we're not doing the sequencing correctly. And that's going to kind of lead us to our poll question for today. And so the question is, what you currently have as your error prevention process in your manufacturing process as it relates to sequencing? Do you have a sequence fastening process, a screw counting process? Do you use both of those, or do you use neither of those? And so I'll give you just a few seconds to go ahead and answer that, and then we'll continue along with the presentation. All right. Thanks very much for participating in that. The majority answer here was, it just changed, but it was a tie for both processes and neither processes. So thanks for participating in that. And we'll go ahead and continue on here. And so often in our presentations, in our webinars, we're constantly talking about the normal fastening challenges that happen during a process or application fastening process. And that could be the fasteners are under torqued. It could be that the fasteners maybe under torqued. You could have fasteners that aren't fully seated or the heads are lifted. You could have situations where there's a cross thread type of an event, or situations where you're fastening into a blind hole and you're not quite sure if that was done correctly or not. So these are all kind of common challenges that happen during any normal fastening process. And if we need to make sure that in a sequence, all of those components get seated correctly, this kind of makes that scenario even more that could be problematic in the actual fastening process. And so how can we safeguard against fastening sequences and tightening failures? So the first one, we want to be able to use error proofing capabilities within a particular tool. So we can make sure that we can track each sequence of the screws during the fastening process. And this is going to help us monitor and track through the process and making sure that all of the fasteners get torqued and that they get torqued correctly. And excuse me, if there is the ability to have error detection as we move through that, again, if there is an error, we can go ahead and address it right when it happens, and we can go ahead and fix it and then move on through the process. And so the one thing that we often don't talk about is going to be the human error risk that can happen within the process. And it could be from assemblers that maybe misunderstand the whole sequencing process. It could be the fact that they have a little experience or they don't have the proper training, or it could be that they just think that they know how best to do it other than how they've been instructed to do it. And that could be evident in the misidentification of parts and procedures. It could be the actual inadvertent errors where they're not really paying attention to what is actually going on. They may be thinking about other things during the actual fastening process. And it could be a lack of supervision or oversight on what's happening during the actual fastening process. So that one system that we have that can help address all of these concerns and help also to provide a little bit more protection is going to be our POSI, or our position control system, which is an all-in-one platform that gives us a controller and then also a torque arm that we use in conjunction with the controller to help us move through the assembly, again, making sure that all of the fasteners get torqued and they get torqued correctly. Now, the position system, as I mentioned, does utilize a torque arm and a controller. And so in this case, we have encoders that are mounted on this particular arm, are going to be an articulated arm. And it's very much like your own arm that hinges. And it also does allow for the angle of the driver to be moved down from 22.5 to 45 degrees as well from this position. But we're monitoring where the tool is in space. And so we can then trigger the DC tool to allow it to function and operate only if the tool is in the correct position for that particular fastening application. And there are also different styles of arms for different types of applications. So another position control arm that we have is going to be a linear torque arm. This allows you for movement for in and out of the tool and also rotate around the column. So that is another type of position control arm. And then if you need a little bit more flexibility in how to get to a particular fastening location, we also have these available in a telescoping type of arm. Now there's a few different encoder type positions that we can use here. One would be a length encoder that monitors the length of where the tool is in relation to the fastener. We could also add a rotational encoder there to monitor the angle of the tool. We can use those in combination of each other, so an angle encoder and a length encoder. And then we can also monitor the total amount of tilt that happens within that arm as well, or we could put all three of those together in one type of arm. So there are a lot of solutions that do allow us to make sure that we can try and help any application for its position control. Now, the control system itself is also going to provide ergonomic benefits because the tool is secure in a torque arm. And so if you have torque values that are above, say, 15 to 20 inch-pounds and higher, you'd want to secure that tool in a torque arm to help prevent any type of repetitive motion injury or any type of carpal tunnel, things like that for the operator, because trying to do that over long periods of time can introduce those types of stresses to the body. And by using the torque arm, it's helping to prevent against that. So not only did you want to use this in a higher torque environment, but it's also very good to use these in a very low torque environment as well. So if we're down in the low inch ounces, a few inch-pounds, it's good to put the tools into a torque arm as well, because now you're getting 100% of transfer from the torque from the tool to the part, and the operator isn't influencing that type of tightening due to any type of side load or any type of leaning onto the tool where it could introduce some inaccuracies at a very low torque value. So those are some of the benefits that go along with the putting the tool in into an arm. Now the the position system also comes with a controller, which almost acts kind of like a cell PLC. It has 12 digital assignable inputs and outputs that allow you to communicate with other devices. Could be light trees, could be buttons or switches or proximity sensors. Could also communicate with a PLC and again any other line control devices. They're Industry 4.0 ready, and they ensure proper sequencing that happens with a particular program. And how the system functions is that it basically will make the tool inoperable unless we're in the correct step within a program at the right location. And so as we look at our demo, we'll kind of go over how this functions, and we'll do a little programming as well to kind of show you how that works within the process and how we can use that to do a sequence-based fastening. And as I mentioned before, the sequencing could be just a sheer number of fasteners on a particular application. It could be where we need to seat a flange or a gasket type of application. And this system allows us to be able to do that and do it very efficiently as well. So the excuse me, the system not only does it provide the sequencing, it does provide screw counting. It does have a job manager function. And so if you have a kind of a high mix, low volume type of scenario where you may have different patterns that you need to use, the system does have the ability to have different jobs stored within it. So you can have up to 255 different fastening jobs. Each one of those jobs can have up to 80 steps in it. And each fastening step within those 80 steps can have up to 50 fastenings. So we have plenty of room to handle large scale fastening scenarios for that. And it's very, very easy to create sequences. And we'll do that here within our demo. So let's go ahead and jump into our demo. So what I have here is our EC DC controller, the Posi Touch controller, and the torque arm in the linear torque arm, and a thread block here. And so what you're looking at here is going to be the controller. And then this is the DPC touch controller. Right now, you can see that the tool is locked, so there's no power to the tool whatsoever. And we do have our thread block here, and we'll be using these 4 fasteners here for our sequence. Obviously, we could do a lot more, but for the purposes of the demo, we don't want to make it too terribly long and bore you. But nevertheless, we do have the tool ready to go, and our controller. And basically what is happening here is the message on the display is telling us where our fastening location is. And so if we come to this location, you can see that the tool will now go ahead and unlock. So we can use that in that location. And so with the DPC Touch, I haven't quite finished the actual fastening sequence here. So let's go ahead and we can look at programming that here. And it's slightly off just a little bit, but we should be all right here. So let's go ahead and we'll log into the system, and we can go to the job manager, and we have our program down here, and we'll go ahead and edit that program. And so in this sequencing steps, we have 2 different sequences. They're both fastening steps, so we can have different types of steps within the actual program. So let's look at our angle step first. We can go ahead and edit that. And let me make sure that this is focused correctly. Yeah, that's not too bad. All right. And so what you're seeing here is our encoders are reading where the tool is in space, and then we have the location of that fastening. And so if I want to go ahead and teach this fastening location to this, all I have to do is go to the tightening process, hit the apply button, and it will go ahead and apply that to the readings. And so if we want to go ahead and update this real quick, we can do that. We can hit apply, go to fastener number 2. We apply it, go to fastener number 3, apply that, and then finally to fastener number 4 and apply that. And so at this point, all of those have been updated. And if we have fastening readings or we have encoder readings that are within the OK zone for those particular coordinates, it will then go ahead and unlock the tool for us. It also allows us to put in the tightening job. And let me just move this over just a smidge. There you go. You can see that a little bit better. Where we can use what preset we want the system to use. So for this particular step within the process, we're going to be using preset number 1. If there's an error, we can tell the system to also use preset 1. Or if there's some other type of thing that we want to have happen, we can call a different preset to be used as well. Now, this also, again, you saw the image where it shows the location. That's done here and through select our image. And we then have the ability to add the actual data point to the fastening location. So right now I'm dealing with position 4, and anywhere I go ahead and press on the display, it will give us where position 4 target should be, but it should be up here. And there we go. So it does make it very easy to load the image, and then we place the target on that image. And as we go through our steps, it will go ahead and provide the target location for the operator. So let's go ahead and close that. And then we can go to our next step, which is going to be our torquing step. And we can edit this and I only currently have 2 positions in here. So we need to add the other 2. So let's go ahead and again add the sequence to that. So we can come to our first one and we can apply that here. Go to our second one, apply that location, go to the third location, and then to the fourth location. All right, and we also need to select or put in the preset for those particular fastenings. And again, so this is our torquing step. So we're going to use preset number 2. And that was for number 4 and number 3. We'll use preset number 2 as well. And we have it preset 2 for fasteners 1 and 2 already. And so now if we save this, we go all the way back out and we save it. Now we can go ahead and load this. And this can be triggered either by a PLC. So as a part comes in, it can trigger which job to use. We could also be done through a barcode scan where we can assign a barcode to a particular job. So that can be done, or it can be done manually, but most likely you'd want to use another input device to select the actual job. And so if I were to go ahead and do this fastening, we bring the tool here to this location. We can go ahead and run this. And this is our first step within the process. And then we get a good signal. And I'm not sure why it's not functioning correctly here. All right. And now we're moving to the final torquing. And then we did not add the image data to the last one, but that is how we could do it. So let's go ahead and do that right now. We'll edit that. And then we'll come into select the image. And then we'll go ahead and add 3 and 4. So 3 is right here, or excuse me, it's number 1. We have to highlight number 3, put number 3 here, and highlight number 4. Actually, number 4 is here. And number 3 is here. So that is how we can do that, and we save it. And then we can go ahead and we would run it again. So since these fasteners have already been fastened, we would have to then go ahead and loosen those back up, but we could do that. And again, you can have a number of different programs within it to be able to do that. And that is how we can monitor the amount of torque that happens. But if we had any one of those errors, we would then the system would go ahead and restart it. So if we go to hit the job manager here and we'll load this one again, when I bring it to the fastening location, you can see it has now changed it back from preset 1 to preset 2 in that area. And since this is an angle step, this should give us an error if I go ahead and run it. And you can see that with that error, it did not count that within our fastening, and we're still left to fasten that number 1. So with that, that is how we can manage sequencing in the use of making sure that all the fasteners get torqued, that they get torqued correctly in the right sequence, and the unit then is managing all of that for us, making sure that we're going through each step and each step is satisfied during that particular process. So with that, that's going to lead us to the end of today's presentation. And so if you have any questions, feel free to go ahead and put those into the chat, and we can go ahead and do that now. So, Chris, do we have any questions?
Hey, Dave, we got a couple questions to start with. Can this system be used with like an air tool?
So yes, the Posi touch system can be used with a DC tool like we're using here. It can also be used with an electric clutch tool where it's communicating with the transformer that's being used. And it also can be used with a pneumatic or an air tool. The tool itself, though, does need to have some special ports on the tool that allow for it to be able to monitor the air that's running through the tool. And it uses a time-based sequencing or a time-based function to make sure that the tool is performing within the ranges of the fastener. But yes, the tool can be used with a pneumatic tool as long as it has the correct air ports on it. It can be used with a clutch tool, electric clutch tool, and also with a DC control tool.
All right. Another question was when you're setting up like, I don't know, the rundown time or the sequence, is there like a number of test samples to do first before implementing it?
Yeah, so if you're doing the time-based functionality where the DC or the tool that you're using is relying on time versus the DC signal sending the signal to the controller, you typically want to do anywhere from about 5 to 6 rundowns with that fastener so you can develop a time signature for that particular rundown. You then enter in a minimum amount of time it takes to run that fastener down and a maximum amount of time for that fastener. And so we can kind of control and making sure that that fastener is seated correctly. If there's an error because it timed out too soon, that would be indicative of a cross thread type of an event. And if it went past the normal time, that would be indicative of a stripped fastener in there. So if you're not using a DC tool to be able to confirm that the fastening was done correctly, then it would rely on the time-based, and then we develop a window for that to help mitigate through other errors like cross-threading and stripping.
All right, Dave, another question we had is there a way to send like a pass fail result to like a floor system or factory on the floor?
Yep. So with the inputs and outputs that are available, we can send a torque up signal on one particular fastening that can go out to another line control device or a PLC. We can also do a batch signal out if there was a torque event that was successful or if there was an error on there. And so both of those signals can be sent to another device.
All right, Dave. That's all the questions we have for today.
All right. Thank you very much for joining us today. And I hope that you learned something today. And if you have any questions regarding the position control system, feel free to reach out to us and our sales team, and we can certainly try to help you with that. So with that, have a great week, and we'll see you next time.